Okay, factoring. So there's lots of different kinds of factoring. This should all be review, except for the sum and difference of cubes. All of the rest of this should be review. We're still going to go through it, but you should know this. This shouldn't be super foreign to you. So in this one, we're going through GCF, greatest common factor, difference of squares, sum and difference of cubes, and simple trinomials. Okay? So let's simplify the following. So if we have a times 3a plus 7, that's 3a squared plus 7a. Good, you know that. You can multiply that, you get negative 2m cubed minus 12m squared plus 2m. You're just distributing in, right? Same thing here, so 4x cubed y times x squared minus 2y is 4x to the fifth y minus 8x cubed y squared. All right, so the simplest form is when it's not factored. So what we got as our equals there. Our factored form is when you pull out what goes into all of it. And then polynomials that can't be factored are called prime. So perfect squares. These ones are some of my favorite ones to factor because they're pretty simple, okay? So perfect squares, let's think of perfect squares. X squared, y squared, 1, 4, 9, 16, 25, 36, 49, 64, 81, 121, 144. What do all these numbers have in common, and what the heck, what's a perfect square? Where do these numbers come from? I know some of you are asking that right now. So that would be like 1 squared equals 1. 2 squared equals 4. 3 squared equals 9. Holy moly, what's happening? Just kidding. 4 squared equals 16. Okay, that's where those numbers come from. So those are perfect squares. And then rules for factoring perfect squares is you just square root both of them. You have an a minus b, and you have an a plus b. And I'm just going to show you that this works right now. So let's take this a minus b, a plus b, and let's multiply it out. So here, so that's going to be a squared plus ab here. So that's minus ab plus, minus b squared. Those cancel and you're left with a squared minus b squared. That's where this comes from. When you multiply it back out, you will get that. Okay? So let's factor this. So 36w squared minus 25. We'll square root both of those. The square root of 36w squared is 6w. And the square root of 25 is 5. So that's going to be 6w minus 5, 6w plus 5. Okay? Seems easy enough. Let's look at this one. 1 over 144 minus r to the 6th s to the 4th. Well, 144 is a perfect square. R to the 6th is a perfect square because 2 goes into it. S to the 4th is a perfect square because 2 goes into it. So we should probably be able to do this. Let's square root both of those. What's the square root of 1 over 144? Well, let's think. What's the square root of 144? It's 12. So the square root of 1 over 144 would be 1/12. Okay. And the square root of r to the 6th, s to the 4th, that's going to be r to the 3rd, s squared. Okay, because you just divide that by 2, divide that by 2. And then that's going to be 1/12 minus r cubed s squared, and 1/12 r cubed plus s squared. 1/12 plus r cubed plus s squared, sorry. Let's do this one. Now this one has a plus sign. Is that the same thing? No, it's not. But it's very similar, and I'm going to teach you this right here. So this gets into complex numbers a little bit, but we can square root both of those still, right? And you would get 4x squared and 1. Well, now the only difference is we have to add i's, so we have imaginary numbers here. Okay, so that's going to be 4x squared minus I and 4x squared plus 1i, which is the same as just i's. And the reason we have i's here, if you're wondering, so if we were to set that equal to 0, so 16x to the 4th plus 1 equals 0, well, that's going to be 16x to the 4th equals negative 1. Divide by 16, divide by 16, and you get x to the 4th equals negative 1/16. We're taking the 4th root. This is getting into stuff that we're going to get into later in the unit, sorry. But we're taking the 4th root, Anytime you take an even root of a negative number, it's an I value. So like it's like the square root of -1 is I. Same concept here. Okay? If you didn't understand that, it's okay. That's a later lesson that we will get into in this unit. So we'll go over this more in class. Yeah. Try to do example F. Now, perfect cubes. This is a new concept, so pay very close attention here. So remember to write this down, blah, blah, blah. Let's talk about these perfect cubes real quick. So 1, 8, 27, 64. That's the same as like the squares. So 1 squared is, or 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. That's where those come from, okay? Now, rules for factoring this. So we have a cubed plus or minus b cubed. Well, when you do these, you're going to have a small parenthesis and you're going to have a big parenthesis. Okay, so cubes, always remember small and big. Okay? And then we're going to remember the SOAP acronym. Okay? SOAP, like what you use to wash yourself. Hopefully you're using soap, or you might be kind of stinky. But the SOAP acronym. So SOAP, it doesn't stand for what you have in your shower or what you use to wash your hands. Well, it does, but in this case, SOAP is, same, opposite, always, positive. And this is the signs. It also always positive thinking. That is something, since this is like the second video, I'm just going to go on a little tangent. There's tons and tons in science to positive thinking and talking positively to yourself. And this being a math class, math tends to be one of the subjects where people talk really negatively towards, and they say they can't do it and blah, blah, blah. Always stay positive. It changes lives. Positivity, look it up, like the power of positivity. Anyways, so this is the signs for the parentheses. So it's going to be the same sign in the first parenthesis. Then the bigger parentheses is going to have the opposite sign and the always positive sign. So the one that's always smiling is in this, I'm just kidding, in the second parenthesis. The positive as in plus, okay? And then the small parentheses stay small. The big parentheses gets bigger, which means the outsides get squared, and the middle term is multiplied together. So for this, small parentheses stay small, so that's going to be a and b. Big parentheses gets bigger, so that's going to be a squared and b squared on the outside, and a times b on the middle. Okay? So let's use this without so many words. So a cubed minus b cubed is a minus b, because same sign. A squared plus ab plus b squared. So same sign, opposite sign, always positive. Okay? Same thing with plus. Again, same sign, opposite sign, always positive. And then the AB, A squared, AB, and B squared, those don't change. And that's something to remember, that these are very similar. The only difference is a sign, okay? And the sign is always, the sign in the first parenthesis is always the same as the sign that's in the parentheses, or that you started with, okay? So sum of cubes, the rules for factoring that is that formula that we just went through. If you want to memorize it, more power to you. I hate memorizing formulas. I hated when teachers told me, just memorize the formula. I was always like, that's stupid. Like, anyways, yeah, okay. So I like to remember this stuff, okay? I like to remember small parentheses, big parentheses, SOAP. Small parentheses stay small, big parentheses get bigger. And don't get me wrong, there are some times that I might be like, sorry, you just have to memorize it. But if I can ever find a trick to not have to memorize just symbols, because I know math is just symbols, I'll give you the trick, okay? So let's look at this. H cubed plus 125. Well, we have a small parenthesis and a big parenthesis. soap, so same, opposite, always positive. And then small parentheses stay small, but what stays small? We need to take the cube roots of both of these. So h cubed, the cube root of h cubed. Cube root in a calculator is math 4. If you're using like a TI 84, 83. I think even like an 89. If you have like a Casio or an Inspire, no idea. I could try and help you out in class, but you're going to have to figure it out. So the cube root of h cubed is h. The cube root of 125 is 5. So that's going to be h plus 5 in the first parenthesis because they stay small. Big parentheses, they get bigger. So that's going to be h squared and 5 squared. The middle term, and 5 squared is 25. Middle term is h times 5, which is 5h. Okay, let's look at another one. So 8f cubed plus 27. Small parenthesis, big parenthesis. Same, opposite, always positive. Cube root the 8f cubed, cube root the 27. So that's going to be 2f and 3. So it's going to be 2f plus 3 because they stay small. Get bigger, so it's going to be 2f squared and 3 squared. And then 2f times 3. Well, it's going to be 2f plus 3. 2f squared is 4f squared. Minus 6f plus 3 squared is 9. Okay? I might want you to try m and n. Let's do one difference of cubes one. So h cubed minus 343. Same process as sum of cubes. So small parenthesis, big parenthesis. Now our signs are just different because it's same, so a minus sign, opposite, plus sign, always positive, plus sign. Cube root both of those. Cube root of h cubed is h. Cube root of 343 is 7. So that's going to be h minus 7. And then h squared, 7 squared is 49. And then that middle term is 7h. Okay, I think you should be able to do L, M, and N, so please try to do those. Let's get into factoring some trinomials. So m cubed minus 13m minus 30, sorry. So to multiply trinomials, we must think that's not supposed to say multiply. You know, if I could get through a video without making a mistake, it would be a blessed day. To factor, that's what we're doing here. We're not multiplying. To factor a trinomial. Sorry about that. What multiplies to be the last number and what adds up to be the middle number. One thing about me, guys, is I make a lot of mistakes and I struggle. But I've learned, because I went through school and I struggled through school and I made all these mistakes. And I always felt stupid because of it. And then I realized there's a lot of power in struggle. You learn the most from your mistakes. So like, I made a typo and I learned that I need to pay more attention, right? But this is getting to a bigger thing. If you make mistakes in my class, I don't ever want you to feel bad about it. I don't want you to feel stupid or anything. It happens and you're going to learn the most from your mistakes. So learn from me. It is totally fine to make mistakes, okay? Just as long as you're learning from them. So to do this, we're going to see what multiplies to be the last number and what adds up to be the middle number. So for this one, we're thinking, what multiplies to be negative 30 and adds up to be negative 13? Well, let's see. Let's write out the factors of 30. So we have 1 and 30. We have 2 and 15. We have 3 and 10. 4 doesn't go into it, so that's sad. And then 5 and 6. And I like to write my when I'm factoring, multiples. When I'm finding the multiples, oh my gosh, when I'm finding the multiples of a number, I like to write it like this. Because notice I go 1, 2, 3, 4, 5, and then I went over to 6 over here. So that means I don't have to put 6 right there. I already found 6, so we're done, okay? Now, do any of these add up to be 13? Well, there's 2 of them that do. Because I could do 15 minus 2, and that's 13. And 3 plus 10 that's 13. But it needs to be a negative 13, and it needs to be a negative 30. Well, which one's going to give me that? So to get a negative 13 with 3 and 10, I would have to do negative 3 minus 10, which would give me negative 13. But if I do negative 3 times negative 10, that's going to give me a positive 30. So that doesn't work. So it has to be the 2 and the 15. So 2 and negative 15 will give me negative 30. And 2 times negative 15 will give me, wow, words are struggling. So 2 plus negative 15 will get me negative 13. 2 times negative 15 will get me negative 30. Okay, and that's what goes in the parentheses. So it's going to be m plus 2, m minus 15. Sweet, let's do another. So j squared plus 3j minus 28. What multiplies to be negative 28 adds to be 3. Let's write down the factors. 1 and 28, 2 and 14, 3 doesn't go into it, 4 and 7, 5 doesn't go into it, 6 doesn't go into it, and I already found 7. So do any of those get me 3? 4 and 7 do, but one has to be negative, so that 4 needs to be negative. That's going to be j minus 4, j plus 7. Okay? And then this one, z squared minus 5z plus 4. What multiplies to be 4 adds to be negative 5. So 1 and 4, 2 and 2. Well, it's 1 and 4, and they're both negative. Okay? Now let's do this one. There is a very high probability that something like this will pop up on a quiz or a test. This is your warning. Okay? If this was x squared minus x minus 20, couldn't we just factor this like the last 3 examples? Yeah, we could. So let's just do that. It's the same except for everything's doubled, right? We just doubled the x squared, we doubled the x, and then 0 power, you can't double that, so the constant just stayed. So let's see, what multiplies to be negative 20 and adds up to be negative 1? Let's write down our multiples. So 1 and 20, 2 and 10, 3 and sad face, 4 and 5. Well, 4 and 5 is going to give me 1. The 5 just has to be negative. Okay? But now, so on the last example, I just put x's in there. This time, we're going to put x squareds in there because we had to split up that x to the 4th, so that splits up into 2x squareds. Okay, I want you to try and do the examples on the last page. We'll go over some of them, not all of them, tomorrow in class. Okay, remember to take the quiz. Thanks for listening to my little side notes. You guys are awesome. Bye.